as you identified, objects move because forces push or pull on them. So if an object is moving, there is a force acting on it, either a push or a pull force. Okay. There are two different types that we're going to talk about, and they are contact forces and non-contact forces. The difference between them is right there in the name. Contact forces are forces where the two objects are in contact with each other. They are touching. If something is a non-contact force, then that means that it is a force that acts without touching the object that it's acting on. So examples of contact forces would be a ball hitting a bat, your foot pushing on the ground, basically any situation where you have two objects that come in contact with each other and one of them pushes on or pulls on the other. Non-contact forces are most often going to be harder to talk about because they are not ones you can actually see happening. Okay? You can see the movement as a result of the push or pull, but you can't see the thing pulling because it's not a visible force. These are things like gravity, magnetism, electrical forces. Okay? These are things that can push or pull on an object without coming into contact with them. They don't have to touch them in order to move them. So, then let's talk a little more about forces. Forces are measured in units called newtons, and we use arrows in diagrams to indicate the strength and the direction of a force. So, if we have a strong force, we're going to use a large arrow. Okay, so perhaps this would be a force of like 300 newtons. Okay. Whereas if you have a weaker force, you're going to use a smaller arrow. So maybe this one would only be about 100 newtons. Now, different motion is going to happen to an object depending on the strength and the direction of the force that you apply to that object, okay? So let's imagine this ball here is sitting on a surface, okay? If the force is applied in the direction that we showed with the arrow, then the ball is likely going to move. However, you could take a similar force, a similar strength force, and apply it in the downward direction, and the object would probably not move. How come?
It's on the ground.
It's on the ground, right? The ground is exerting a force on that ball. And the same force that would cause it to move sideways is likely not enough to cause it to move down into the dirt. It would take a much stronger force to do that. Okay? So, not only the strength of the force matters, but also the direction that it's applied. Same strength of force here, but a different direction of application results. One results in movement, and the other one doesn't. So you have to take into account how strong is the force and in what direction is the force applied. Now let's get into a force, a specific force, the force of gravity. Okay, the force of gravity is the force of attraction between all objects. And because it's just a force of attraction, it is a non-contact force. Here on Earth, it's really tempting to think about gravity as just the force that the Earth exerts on us. However, that's not an accurate view of gravity. The definition there doesn't say the force of the Earth pulling on you. The definition says the force of attraction between all objects. So the Earth exerts gravity on you, you exert gravity on the Earth, you exert gravity on the objects around you, but the fact of the matter is that because the Earth has such a large mass, that its force of gravity is going to pretty much overrule any other nearby forces of gravity. It's why objects don't just fly off of the surface and get stuck to the moon. The moon has gravity, but the gravity from the Earth is so much stronger that it holds objects to it. If you were able to take yourself and another object out into outer space away from any other sources of gravity, you would likely be able to sense that attraction force between you and the other object. But because we're here on the surface of the Earth, so close to such a strong force of gravity, we do not often feel it. The strength of gravity is affected by two factors, which we kind of just talked about but we're going to talk about them a lot more specifically, okay? And those are mass and distance. As mass increases, the attraction between two objects will also increase. So if you have two small objects, they will definitely have forces of attraction between them. But if you increase the mass of one of those objects, you are going to see that force of attraction increase. As you continue to increase mass, you will see more force between the two objects. So to summarize, greater mass equals more gravity. You could write that underneath. The greater the mass is, the stronger gravity is. Distance, on the other hand, goes the other direction. As you increase distance, you actually decrease the strength of gravity. So two objects that are close together are going to have forces of attraction that are relatively strong. And as you spread them further and further apart, those forces of attraction are going to weaken. So you could summarize that by saying larger distance equals less gravity. So as mass increases, gravity increases. As distance increases, gravity decreases. When we're talking about gravity, we have to also mention weight. Weight is a measure of the pull of gravity on an object. So, as gravity increases, so will the weight of objects. This is why your weight here on Earth is more than if you took your weight on the moon. Gravity on the moon is about 1/6 what it is here on Earth, so your weight would be roughly 1/6. Weight and mass are not the same thing. If you remember, we talked about mass increasing and increasing the effect of gravity. Okay, your weight and your mass are not the same thing. Your mass is going to stay constant no matter where you go. It's how much stuff you are made of. The only way to remove mass is to actually take substance away from you. So I'd have to remove a limb or something to change your mass. But your weight will change depending on the force of gravity. So if we decrease gravity, your weight decreases, but your mass will remain the same. However, weight is proportional to mass. That means that as objects' mass increases, their weight will also increase because it's a measure of how much gravity is pulling on that mass. So if you remember, as your mass increases, gravity increases, so that pull of gravity will be stronger and your weight will go up. Because the Earth is so massive, you would have to get a very, very long way away from the surface of the Earth before you saw a difference in your weight. The astronauts that are living on the International Space Station, that's miles above the surface of the Earth, are still close enough that their weight really has not changed that much. You would have to get way far away from the Earth, out from the pull of its gravity, in order to see a significant change in your weight. Let's talk then about friction. Friction is the force that resists motion between two objects. And because it's resisting motion between two objects that are touching each other, it is a contact force. There are two causes for friction. Cause number one, the one you're most familiar with, is that all surfaces have microscopic dips and bumps on them that catch on each other. Even smooth surfaces, like the surface of your desk, feels pretty smooth. If you looked at it with a microscope, you would see it in fact had lots of ridges, dips, bumps, and things. And when two surfaces that have those kinds of bumps on them slide past each other, oftentimes those bumps catch on each other and they cause forces that resist those objects moving past each other. The other factor that you may be a little bit less familiar with is that all matter is made up of atoms, and atoms have electrical charges. And so as those atoms move past each other, those weak electrical forces cause attractions between particles, and that can cause forces that resist movement. There are 3 types of friction that we're going to talk about. Okay. There is static friction, which is the friction for an object that is not moving. This is what keeps surfaces from sliding. So if you set your iPad down on your desk and it doesn't slide off, that's because there is static friction between your iPad and the desk, okay? Static friction is going to continue to increase as forces increase until it reaches a limit, and then it will allow the object to slide. So you can think about this, right? If you have a heavy box and it's sitting on the carpet, you push on it, and you're pushing harder and harder, and eventually the box starts moving, right? But up until then, it feels like the box isn't going to move. And that's because as you're increasing your force, the static friction is increasing to match you until you get to the limit where it cannot do that anymore, and then it gives over to sliding friction. Sliding friction is friction between two objects that are moving past each other, and it's actively working against motion. Okay, so this is the friction that you have when you are sliding that box across the carpet. It's constant, which means the force of friction while it's moving is not increasing or decreasing, which is why it's not necessarily going to get harder to push that box as you're moving. But because that force is constant, if you decrease your force, the box will begin to slow down. And if you increase your force, the box will begin to speed up. The force of friction is constant there. The last type of friction we have is fluid friction, which is friction between a surface and a fluid. Fluids are gases and liquids, so water, air, other things. Any gas or any liquid can exhibit fluid friction. This decreases as surface area against it decreases. So you can think of the classic dropping a piece of paper or dropping a crumpled piece of paper. The one with more surface area is affected more by fluid friction, which we know as air resistance, than the one that is crumpled up because it has less surface area. Ways to decrease friction. You can decrease friction by decreasing the amount of surface area that's touching between two objects. So think about this in terms of something that's on wheels and something that's not on wheels. If you have a box on the carpet, the entire bottom surface of that box is in contact with the carpet. So all of that surface area is experiencing friction. Whereas if you have a box on four wheels, only the very bottom portion of each of those four wheels is touching the ground. That's a significantly less large-sized amount of surface area. So you have less friction to overcome, which is why a box on wheels rolls easier than a box that is just sitting flat on the ground. And the other thing you can do is you can attempt to fill in those microscopic dips and bumps with some kind of a lubricant. So think about this in terms of if you put soap on your hands, right? Your hands feel more slippery, they slide past each other more easily because all the little grooves and bumps on your hand have been filled in by a layer of soap. The same is true if you add graphite to a bike chain or oil to a car engine. You're filling in all of those dips and bumps so they no longer catch on each other, and as a result, you have less friction. That is where our notes are going to end for today.